Awesome. So I also changed the title a little bit, put the iOS and the Swift stuff first, because everyone here is probably more familiar with iOS and Swift than with Android and Kotlin. That's my assumption anyway. So just a quick, who am I? Website, Twitter, and this is a link to the slides if you are interested in following along right now. Or if you want to make it look, I can then believe that you're following along with me if you're doing something else on your computer. So I will send the slides out, so you don't have to worry about taking this down if you're just interested in keeping up after the talk. That's what I look like on the internet. There's some similarity, but not a whole lot. So what are we going to talk about today? So these are my goals for the talk, and what this is supposed to represent is that what I would like is for you to end this talk face palming, and the face palming that this is you, and the face palming that you're going to be doing is because you've realized that you built up all these skills related to the iOS ecosystem, and the jump that you would need to make to transition to the Android and now Kotlin ecosystem is so much smaller than all of that work you did the first time around. You get a second platform for almost free, at least a lot cheaper than you got your first platform for. So that's why, that's the goal. That's why I want you to be face palming. This is not going to be this language is better than this language talk. It's not like an angry talk. It's not like an eggplant measuring talk. We're just going to look at the differences and the relative merits, but it's not to put one language down. And it's not going to be the deepest dive ever. I'm not in scientist with test tube mode. It's going to be a little bit more pragmatic. That's the aim. So why would you be interested in this talk at all? Why would you be interested in the Android ecosystem and Kotlin? One is that it's just nice to expand your tool set, as I'm sure Jeff can tell us. Learning TypeScript, it's just nice to have more tools available in your toolkit. It makes you more employable. It's also nice to step outside your own ecosystem for a while. This is middle-face thinking. It's nice to step outside your own ecosystem and see how it's done in another ecosystem. You can bring back some of the best ideas from your new explorations to your original ecosystem, sort of gets you out of the bubble and prompts you to think a little bit. And then, more tools means you're more valuable to your employer. So those are the goals. The way this talk is structured is as follows. We're going to look through some common topics. So what I tried to do is think about the tools and techniques that you need to use to build iOS applications and focus the comparisons around those. So it's not sort of an abstract language theory deep dive talk. It's if you were actually going to make this transition, you would need to know how to do X, and it looks like Y in the Android and Kotlin ecosystem. And then I'll end the talk with a couple of resources and tactics for if you were interested in making this transition, how you would go about doing that, and then space at the end for Q&As. So the three main topics are going to be languages, which is the big chunk of the talk, and then a little bit on architecture across the platforms, and also layouts, building layouts across the platforms. There are lots of things which are not topics. This is a small sample: application lifecycle, networking, CI, distribution, soft skills. The point of listing all these here is, again, to make you realize that a lot of the hard work that you've done already to reach this point in your developer career is totally transferable. A lot of this is very easy to move from one platform to the other. So bear that in mind. We're not talking about having to repeat your whole career to date. There's a lot that you carry over with you. These are also not topics, and these are candidates which could have been topics, but really I didn't have time for. I'm not going to talk about IDEs that much. The important thing to know is that the IntelliJ family is a much better IDE than Xcode, and I'm going to leave that there. And the second thing I'm not going to talk about extensively is frameworks. And if there was going to be a sort of a catch to this talk, this would be the catch. One thing that you can't escape is spending time with to get to know the framework. So that what I mean by this is it's all of the classes that are exposed by the framework and framework patterns and the structure which you work within. So we're going to talk about things like the language and the architecture, but not how do I make Bluetooth work on iOS versus Android. That really just comes with time. So before we dive in, let's do a quick level check, not a microphone level check. This is the kind of level check I am referring to. Is that clearly distinguished? Oh, kind of, just enough. So this is my self-assessment of my relative skill sets. This does not mean I'm a perfect Android developer. This means that I know Android better than anything else on this list. So relative to how I know Android, I know Java fairly well, and I'm still learning Kotlin. I haven't written any production apps in Kotlin yet, but I've been working with Kotlin for a year and a half or so on side projects. My iOS knowledge, this is sort of thinking about the iOS framework. It's been a while since I did iOS production work. It's been coming up in 2 years, 1.5 years. I've never touched Objective-C. Like, I've seen it in the wild and I've kind of been afraid, just turned around and gone the other way. So bear that in mind. I don't have that context to bring here. My knowledge of Swift is better than my knowledge of iOS. Again, it's a little out of date because I finished up around Swift 2.
Are you doing like web backend Swift?
No, I haven't. I haven't touched Swift in a long time. My exposure to Swift has been by working on a corresponding Android projects where I've been able to make fixes in the iOS code base and go in and steal functionality, all the good parts that come from knowing both languages. So I've been reading and stealing and tweaking, but I haven't written extensive production Swift code lately. Everything in here should be Swift 4-ish, but we'll see. You can call me out. So I'm kind of curious. So there are some assumptions baked into this talk about what you all are like and what your skill sets are like, but I'm kind of curious. Is there anyone who thinks they're a stronger Android developer than an iOS developer? Or is everyone like, yeah, okay, one candidate. Objective-C versus Swift. Who would consider themselves more fluent with Objective-C than with Swift? Okay, and presumably, is everyone else Swift more fluent than Objective-C? Whew, okay. And has anyone worked with Java or Kotlin before? A little bit? Okay.
One day.
One day? Okay, that was enough. And why are you even here, Jeff?
It was in prison.
Oh, well, that explains a lot about you, Jeff. That explains a lot. Okay, so first topic, languages. So let's look at some of the principles behind the languages. I think this is where a lot of the similarity between Swift and Kotlin comes from. It's not so much that they were designed in parallel and people deliberately set out to make them the same, but they're based on very similar principles. So these are all sort of pulled from the websites of the languages and their own descriptions of themselves. So we can call them safe, expressive, concise, multi-paradigm, fast, and interoperable. A lot of these I would just say are what languages are touting as modern these days. And they also share common inspirations like Scala. A lot of the stuff that we'll see will be inspired by things like Scala syntax. I'm not going to say anything about speed or interoperability. Just know that they're both fast enough for what you want to do, and interoperability is not a hassle, particularly for either. So let's run through some syntax and capabilities of the languages. This is the chunk of the talk where there's probably the most dense code, and it's also a chunk of the talk where my pitch to you is, look at these two things, they're basically the same. So if you're going to tune out for any part of this talk, this is the part to go to sleep for. And then I'll wake you up when we get to the parts where it starts to get a little more different and the comparison's a little more interesting. So don't feel bad if that happens to you. So like I say, we're going to run through this thinking about specific examples that we might run into in real life. Here is a class that represents a user. This user class in both languages is set up with a first name, which you must provide, and a last name, which you may provide. So these are our two properties. Notice the only difference between these is using the let keyword in Swift versus the val keyword in Kotlin, but they're expressing the same thing. This is not something that can be reassigned after it's been initialized. And the question mark is expressing optionality in both those cases. So that's the whole, I can let last be nil in Swift, or I can let it be null in Kotlin. Does not have to be provided. When I construct an instance of this class, in Swift I use the init keyword, and then I can pass in my first name and my last name. And I can also provide default values. So that's what's happening here for the last name. The default is to say, if you don't give me a last name, the last name is going to be nil. Same exact thing in Kotlin, except that you have to write the word constructor instead of the word init. It's a tragedy, I know. Also, null versus nil. That's one of the things I screw up most often, switching between the languages. Whichever one I've most recently been writing in, that's the nil or null that I write, and I let my IDE correct me. And then within this initialization, I populate those fields that I defined. The only difference here is that in Swift, I would refer to the current instance as self, and in Kotlin, I would refer to it as this. This is less crazy than the JavaScript this, Jeff, don't worry. Just refers to the current instance.
Does Kotlin get the synthesized, I guess it would be constructor that Swift gets?
Tell me more about this synthesized constructor that Swift gets.
Well, if you define the class in Swift as just the properties, it would automatically have an initializer already that you could feed first and last to.
Isn't it only for Structs? Member-wise initializer.
Yeah, it's just for Structs.
So it definitely is true for struct. I will say
Oh, okay.
this constructor syntax that I'm using here, I'm being slightly less than fully idiomatic just to make clear there's a true parallel here. There is a shorthand for this where you just define these in parentheses after the class, and that's implicitly a constructor. And then you don't even need to write the properties, you just write them in that implicit constructor. So this is a little bit more verbose than you would actually end up writing in Kotlin, but yeah, functionally equivalent. So let's say I want to make a user. I'm going to make a me user because it's my talk, so I get to have the ego there. So in both cases, I would say assign the Stuart variable to a user. I'm specifying the first and the last names here because I have both of those. So type inference, John, look at that. It's already here. In neither of these cases do I have to specify the type of that variable. It can be inferred that it is of type user, not something we get in Java for sure. And then the syntax for specifying those two parameters is slightly different. In Kotlin, I use an equal sign, and in Swift, I use a colon. But super similar. String literals, everything. Pretty much the same. Swift and Kotlin both also have property access syntax, so I don't have to write thousands of getters and setters through my Java code base. I can just use properties, and life is good. Same for the last name here. A little funkiness, I'm sure you've all run into this by now with Swift. Something that's optional. This is designed here to indicate that the optional handling under the hood is a little different between these two. From the point of view of someone writing in the language, it's not that different. It only crops up in weird edge cases like this. So even though we know there's a value inside that optional, in the Swift version of this code, it still prints out the optional bracing and forces me to explicitly unwrap it or provide a default value. Not so in Kotlin.
Yeah,
What
the
happens
statement
in-
would have a warning.
Yes, it would have a warning in the IDE, which I ignored while I was writing this. Because I wanted them sort of kind of the same. But yes, yeah, there are easy ways around this.
In Kotlin, what if it's nil? What does it print? It's actually null.
That's right, Dad. Just sit on your hand. Just sit on your hands. It's fine. It's fine. So yeah, so I'm going to exercise this case. Don't worry. So my second canonical user after myself, of course, is Eminem. And Eminem, as far as I'm aware, he doesn't have like. I mean, he does. His real name has a lot of thing, but it's not. There's no second name behind Eminem. So this is a user who has just a first name. So again, I don't know if you remember in the user definition, but our last name in both cases had a default value, which was nil/null. So here, if I don't specify it inside this user class, I now have that nil/null last name. So the first name access is exactly the same. This is what happens if you access. You will just retrieve the value nil or null. And if you print the value nil or null in both cases. Does that answer your question? Well enough? Okay, cool. So then the next thing you probably want to do after you've made a class is start defining methods on it, I'm going to say. So this is a method that prints a full name representation for a user. So the declaration of the methods is pretty similar. Func versus fun, a little more fun in Kotlin. Hey, that joke's never going to get old. And the indication of the type, Swift uses the arrow to indicate the return type, and Kotlin uses the colon, which is perhaps a little bit more consistent with how types are represented through the rest of the language. Array literals and, in general, literals of collections are a little bit more verbose in Kotlin. This is one of the highest voted. Please fix this for Kotlin. You have to write array of or mutable array of to initialize arrays. But fundamentally, these two things are doing the same thing. And then this is the biggest win coming from Java. It's Kotlin. I don't know what it's like from Objective-C to Swift, but having fluent collection operations is the best thing ever. Not having to sort of iterate over this thing. I mean, this is obviously a slightly contrived example because there's only two things in it, but not having to write ugly iterators, but being able to instead manipulate operations in a fluent way is... Yes, and chaining those operations so that I don't have to write everything on a separate line or a separate loop. And again, you can see here that the actual invocation names of these things are slightly different, but we all work in IDs, right? No one's writing command line. No one's writing their iOS apps in command line. So you have your IDs auto-completion and suggestion available to you. So this is a case where if you want a thing to exist and you start typing it, it probably will be there, or some variation of it will be there. It doesn't take long to find. One thing I will note here is that in Swift there is the requirement that you provide an argument name if you haven't done that little underscore trick when you define the method. Not so in Kotlin. So in all the previous examples, I've explicitly specified first and last, for example, in the user. That's a choice that you make at invocation time. So I tend to use it if I have multiple parameters of the same type, where it helps to get disambiguation. But it's not required if it would not otherwise be ambiguous. So here I've left it out because it's fairly clear to me what is going to happen when I provide this string to the join to string method. So with these two methods, if I was to invoke the methods here, the method invocation syntax is exactly the same, nothing fancy going on there. And I get what I would expect. I get my name separated by a space, and Eminem, he's just Eminem. He is pretty cool. Any questions on that so far? Feeling pretty good about
parameter labels. Does the language require you if you have parameters of the same type, or is that just convention?
It does not. It will follow the it will assume that what you are passing in is in the order in which they were declared.
Right. So you could have 6 different parameters with no labels at all.
You could, yes. In that case, that would be somewhere where I would recommend in Kotlin providing those labels. In Java, you're out of luck. There is no way to invoke with labels. IDEs have over time developed the ability to show you those hints because it's a problem. But yeah, it's slightly more flexible than with Swift, where you have to declare at the time when you define the method what the invocation is going to look like. Okay, another huge win, especially coming from Java, because this does not exist in Java in any way, extension methods. So in this case, what we're doing is taking the string type and adding an extension to capitalize something. I know there is already a capitalize method in the Swift standard library. There's also one in the Kotlin standard library. This is just a really neat example to be able to show, so don't worry about that. I'm not stupid. Not in that specific way. This is sort of one of the first deviations we see. The method for defining what one of these extensions is going to look like. So in Swift, we wrap it in this extension string thing, and then we define functions within that. In Kotlin, we declare this all in one go, and we say this is going to be a new function on string by writing fun string dot cap, and then whatever else we write just becomes an extension function. A little bit more magic seeming, maybe. And then the body of this extension function is no different from the body of any other standard function. Nothing funky has to happen here. One thing I will say, I know there are some lovers of the guard pattern in the room, Anne. And one of the things that I found myself doing after writing Swift for 6 months and then coming back to Android apps in Java was just stealing that pattern in a slightly less good way. So that's what this is right here. The nice thing about the guard statement is, of course, that you actually get to write the condition that you would like to be true inside the guard statement and then handle the other case. With the if statement, you're sort of invoking that and saying, well, if the condition I don't want to be true is true, then do the return. But it's a pattern that I feel good about having stolen for Android apps, especially if you have multiple of these conditions. It's a lot nicer than doing all the nesting. So this is an example of how you can, bend a language a little bit to fit your own style. And then what I'm showcasing here is that there's a little bit more flexibility in Kotlin with respect to casting and matching types. So drop one here, first here is of type character, and drop one is of type string, and Kotlin is automatically coercing the character type to match the string for me. And Swift is super rigid. You've got to tell me exactly what you want. In this case, that means if you're going to try and stick this character onto a string, you need to turn that character into a string first. So personal preference as to whether you consider that boilerplate or not. I don't really mind either way. So then, just to prove that this is working as intended, if you call .cap on a string literal in this case, you get what you would expect. Can you imagine working in Java without this? It's like the dark ages over there. You can't imagine working in Java? Well, yeah. Okay, so this is the original full name method that we defined. So I'm going to do a little bit of adjustment, and I'm going to insert a map over that where I capitalize every element of my array of parts of name. Pretty much identical syntax. Slight difference here is that in Swift we're forced to unwrap even though we've removed the nulls with the nils with the flat map, Kotlin is inferring that if we've done a filter not null, then we can't have any nulls remaining here, which is why I don't have to do any unwrapping. If I did have to do unwrapping, it's using 2 exclamation points instead of 1 exclamation point to do that.
I don't understand why you have to force a wrap there. The flat map result should be just an array of string.
It was not when I wrote this. But we can talk about that afterwards, because I was curious about that as well. It was like it had removed the nulls, but it hadn't done any type changing for me. So yeah, I know. So maybe that's a foobar. But yeah, again, fluent collection operations, mapping, filtering, all of that good stuff, pretty much the same, very discoverable. Training, closure, syntax, you name it, it's pretty similar. So yay, now if I print full names for myself and for my friend M&M, then they look a little bit more respectable. They have capitalized portions. Brilliant. Okay, something else which is kind of cool, computed properties. So in this case, what I'm doing is computing a property which gives me my name in, or any name for a user in reverse, separated by a string. So I could have done this without invoking the full name method. This is not the most optimal way to define a computed property, but I'm doing it this way just so I can showcase even more collection operations just because I like them that much. So the declaration is slightly different compared to instance methods here. We replace the func with a var and drop the parentheses in Swift. We have to do this explicit specification of the fact that this is a get method in Kotlin, but otherwise it's pretty similar. And this is an example of Kotlin where Kotlin was skipping the curly braces and allowing you to sort of directly assign one function to another. That's a slight difference that's creeping in here. But again, otherwise super similar. Maybe I'm wrong about this again, John, but there's an explicit cast in here. When I do the split, I get an array of something. I get an array of substrings, which I then have to cast up to strings. But if you look at it,
Yeah, well, you would be able to use reversed on them and join as well.
I feel like join was the one that was complaining about this. But skipping that explicit cast, again, splitting, reversing, joining the string, all super similar. Told you this was going to be a pretty straightforward piece of the talk. So now if I want to get the reverse name, I access using the same syntax as I would for a regular property. Nothing differentiates this from a regular property as a computed property. And M&M stays the same, boring. But my name is now Kent, Stewart. Just the way I like it. All right, enums. So this is where there starts to become a little bit more deviation. And a little bit more sort of interesting language design going on here. So if I wanted to define super simple enums, in this case types of credit card, then the syntax is pretty similar. I don't need the cases in Kotlin, and the naming convention is different. I feel like the naming convention for Swift has changed since I last wrote Swift enums. Did they always used? Okay, they used to be like capitalized like a class. Okay, my brain still prefers the Java Kotlin syntax, but I think that's just exposure. So if I want to switch over an instance of this type, here I'm defining like a small function which is going to build me the end piece of a URL based on the type of credit card. Again, we've seen the signatures of before. Swift uses the return arrow, and Kotlin uses that colon to express the return type. Swift uses a slightly more traditional switch keyword to indicate that we're going to be switching over something, and then uses casing to figure out which of the types of that enum or which of the cases of the enum we're looking at. In Kotlin is, I don't know why they removed the switch keyword. There is no switch keyword in Kotlin. I fail to understand this, but they use when anyway. When is slightly more capable and does a bit more pattern matching, so maybe there was some sort of idea of breaking with tradition there, I don't know. But again, although the syntax for invoking is slightly different here, structurally very similar, there's no need for a case statement. And instead of Swift uses the colon here to sort of jump into the method, and Kotlin's using the arrow, so they're reversed from their function return types. One other neat thing saves you typing return 3 times is that a lot more things in Kotlin are expressions than were in Java. So you can return the result of a when statement like this. You can return the result of an if statement. It's not a huge deal, but any little reduction in duplication we can get away with is nice. And the important thing about these being enum classes, of course, is that there's no default case required for either of these. We know that they are exhaustive. I had some highlighting going on here, but I think it was basically to highlight the stuff that I just said. Yeah, no default case required. Awesome. So now if I was to call one of these methods and provide an instance of the enums, I guess not really an instance necessarily, but again, I need to provide the label here for the Swift version. I don't need to provide that label for the Kotlin version, but the results are the same. We would pick out whichever one of these cases was relevant to us and return the corresponding value. Slightly more fun now. So one of the most exciting things for me about using Swift enums was the ability to have associated values with those enums. And this for me is sort of the canonical case for using that construct. So what we have now is instead of an enum representing the type of payment method, the type of credit card, we have an enum representing the type of payment method. So one example would be just cash. But another example would be I'm going to pay with card, and that card has a number. So if I didn't have the ability to specify different pieces of information attached to different cases of the enum, then what I would probably have to do is have a string representing the number in the card, and the cash would also have a string that was just nil or something really weird. Doesn't make any sense, right? I'd have like extraneous information sort of hanging around here. So I love this feature of Swift. Not a thing in Kotlin. Not a thing in Java. Kotlin enums don't do this, but Kotlin has this sealed class construct, which basically gives us the ability to obtain the same functionality, just with a little bit more code. So here's what using one of these would look like. If you're not familiar with this in Swift, we'll just run through that first. If I switch on the value that I get passed, very similar to the first case, for cash, it's pretty much identical to what we just saw for the credit card types. So I would just say, okay, if I'm in the case where I am looking at cash, then I will return the simple string cash. What's happening over here in Kotlin is that this is now not considered an enumeration as such. What we're doing is an instance of check with that is keyword. So rather than saying just pattern match against the instance of the enum, we're saying, is this this is a subclass of method, is it the subclass cash? If so, just return the string cash. Where it gets more interesting is when we're looking at that card case. So here in Swift, what I'd like to be able to do is say, okay, if I'm in the case where I'm looking at a card, I also want to be able to reference the number for that card because it's going to form part of my URL. Don't quote me on the URL design here, probably terrible, but string stuff, it's easy to represent.
Please don't actually do that.
Yeah, no, I didn't think about it until I wrote it, and I was like, I should put a caveat in there that you shouldn't build URLs like this. It's not great. So what's happening in the Swift case here is that I'm saying, okay, when I have a card, also bind the value of that string to the variable num so that I can access it and use it. And then when I'm returning a value, I'm saying, okay, the endpoint now is going to be /card / and then a string interpolated value of that card number. No default case required for Swift. So I'm going to step back through this and look a little bit more at the Kotlin version of this. So the sealed class here, this is an honest to goodness class. What the sealed keyword is telling us is that this is going to be a class where we strictly control what subtypes are allowed. So you'll notice that this cache class, for example, this is the syntax used in Kotlin to express inheritance. So this is saying cache is going to be a subclass of method. The only place we can define subclasses of method as a sealed class is right here in the same file, maybe even within the class, I forget. But basically we have to declare all in one place what our subtypes are going to be, and then there's no other subtyping allowed as part of that class being sealed. So what it gives us is the guarantee that when we are looking at this class elsewhere in the code, if I switch on instances, I know I only have to check the types of the subtypes that I declared here. It will give me that guarantee of not needing to put in a default case. So that would not be the case if this was just a regular class. You can check as many instances of as you like. It could still be something else. That's the guarantee that we get here. And otherwise, the way we construct it is very similar. So again, that's what this is keyword is saying here. It's saying if this is an instance of type cache, do this thing. This is what it looks like for the card. So what we get here is we actually get smart casting. So this method was originally of type capital M method. Now, because I've checked that it's an instance of card, it's automatically been cast for me to an instance of type card, so I can just directly access the num property that I have in there. And again, the whole thing with this sealed class, just like the Swift enum, is that it knows I don't have to have a default case here. So equivalent constructs, a little bit different implementation, but both super useful, especially with payment methods. That was yeah.
You don't need to switch on method. Like maybe it's just a method and not any distinct subtype.
Yeah, is a method inherently like an abstract class?
No, you might have to, if you're going to do it like really well, you might have to add a private constructor to method just to make sure that you can't instantiate it unless you're doing so through a subclass. So yeah, in this case, there might be a slip, and it might be possible to instantiate instances of just method, but marking the constructor as private for method would allow you to get around that. And because you're required to declare your subclasses within the same file, they would automatically have access to that private constructor. So it wouldn't be a problem to do that. But yeah, nice catch.
Well, then how is the when exhausted at that point? Shouldn't you also do method check? Like you check cache card, but couldn't it also just be a method?
So that was Josh's question, and part of being able to resolve that is I don't know if it's the case. It may be the case, and I don't know it, that you just can't instantiate a sealed class. If that was not the case, then I would imagine that what you might be able to do is mark the constructor private so that it's impossible to generate your own instances of it, and only allow generation.
Can't match against that type.
Well, yeah, that would require a bit more compiler magic, so I wouldn't be surprised if it was actually the first option, but I don't know the answer off the top of my head. But yeah, it's a good question, and I know this is true because I wrote this in code, so I know that it's the case that it wasn't warning me, hey, what about method? So something's going on here. I just don't know exactly what it is. Cool. So then if I, just to illustrate using these methods, if I was to pass an instance of card with the number 1234, then I would get the URL that I was expecting, /card/1234 in both cases. Any other questions on that? It's kind of a big chunk of thinking. Okay. So this is what, so far I feel, this is the part where it's like, so far so good. Like these two languages are pretty similar. I would feel good about switching between them. The syntax is a little different, but functionally I can get to the same place, maybe in a slightly different way. This is where it starts to get a little bit more different in ways that we can't really reconcile. So again, even more thinking required. This is one of those parts where you'd wake up now if you were previously asleep. So the struct type in Swift, we mentioned it a little bit earlier. If I just want to wrap little pieces of data up in and have them be sort of immutable and pass by value, this is the way I would do it in Swift. I would, instead of saying class user, I would say struct name, and I would define my properties. And I think this is what you were saying, John. The synthetically generated constructor is generated for that struct, so I can say, cool, make me a new instance of name and provide first and last name. And the kind of equivalent to this in Kotlin is what's called a data class. So again, it's a class that's modified with this data keyword. And this is the syntax I was alluding to before, where I said, I don't need to write an explicit constructor. I could, in theory, make this more compact. This is basically the way that you would define a constructor that initializes properties on the fly. So this is the entire class declaration. Notice there's no like curly braces or anything after this. It's generated purely from that signature. But just like Swift's structs, I get a generated synthetic constructor that will allow me to make instances of this thing. One slight difference here is that, as far as I know, in Swift, there's no way to avoid having to explicitly pass this null if I want to make, again, my M&M name. If I want the last name to be null, then I have to pass that in. Because of the way this is declared in Kotlin, and because it's analogous to just a constructor, we can provide a default value just as we did before for the user. And so it's a little bit cleaner, maybe there at invocation time. This is kind of like, I feel like, in that case, this is kind of like the previous example with enums having associated values, where we could, with a little bit more work, make Swift work exactly like Kotlin is working here, and everyone would be happy at the end of the day. However, this is the big catch here. So the big thing about structs in Swift is that they're value types. Yay, passing them around safely, don't have to worry about mutating copies, etc., etc. These are still reference types in Kotlin, so if I pass one around, I can like do weird stuff to it. That's generally not the point. Generally, people try not to do all that mutation of stuff in Kotlin, but it's something you can do, so it's something you have to be wary of. There's a little bit of mitigation built in the sense that as well as generating that constructor that we used for the Kotlin class, it generates this copy method which allows you to easily make a new instance but identically initialized copy of your data class. Yeah, so this copy constructor, I could just call this this copy method, but I could call this with no parameters and it would generate an identically valued but different instances of the same class. So in that sense, I can kind of fake the passing by value by just generating a new instance and giving that to my methods. It's a little bit more boilerplate maybe, and it's not perhaps the intended usage, but it's something at least. Another difference that I haven't written down here, but that I can say is that as far as I'm aware, structs don't support any inheritance. Data classes now do, as of Kotlin 1.1. I don't know if that's super useful. Haven't had a chance to use it for anything yet, but okay. This is where things start to get hairy. So protocols in Swift. I'm sure you have all used protocols in Swift. They are a big feature in the language. Here what I'm doing is saying, okay, if you are going to conform to this protocol, you must provide me a function called initials that will return a string. In Kotlin and in Java, we call those interfaces. And again, the declaration of the method that I'm expecting, fun initials of type string, the declaration of the signatures of these methods are identical to if I was actually defining the method right here, right now. So if I am going to conform to this protocol or implement this interface in my class user, this is what I would do. I would say, okay, class user colon initials provider. I forget if I need like an any object or an any or something here before the. I forget if that is going to. Okay, good. So the only difference here is there's a space. I don't know why this space is a convention in Kotlin before the colon. It's the only place where they space it like that. But both of these are basically indicating that you're going to adopt and provide the functionality that was guaranteed by that contract. So again, like I say, the signatures of the methods will match exactly what you've written in the interface. The only difference here is that this is considered an override in Kotlin and in Java, and it's not considered an override in Swift. This is a big tripping up point for me when I was moving to Swift for the first time. I kept on wanting to write override in front of everything because in my mind I was overriding, but Swift is a little bit more. I guess in Swift the viewpoint is if you are replacing functionality, you're overriding, but if you are implementing for the first time, then you are not. Again, the body of this is as if I was writing a regular method. There's nothing special here because it's a method that came from an interface, and again, just more opportunities to demonstrate really fun collection manipulation. So one thing I was going to point out here again, what was I pointing out here? Oh, yeah. So in Swift, if I call that first property, then that's something that can be optional because my collection could be empty. And so I have to explicitly unwrap it. I was a bit naughty here. I probably should have checked that it was not empty first, but that's how you would explicitly unwrap in Swift. We've seen that before. You might be wondering why I don't have to do the same thing in Kotlin, because the same thing is definitely true of the collection. The collection could definitely still be empty. So this is just a slight philosophical difference. There are generally pairs of methods like this in Kotlin. This is one of the pair first. The other of the pair would be first or null. And what will happen is if you call first and there is no first, it will throw an exception rather than just returning you null. So you have a choice here of whether you would like this to be something where you return null and explicitly handle it in your code, or if you're like, I am so sure this is right, I'm just going to throw an exception and crash my program if it's not there. Minor philosophical difference there. Now that my class user conforms to this protocol, I can call that initials method. I could call that even if I knew that all I had was an initials provider and not an instance of user. And I get my initials SK and Eminem's boring initial E. So one thing you can do in Swift with protocols is you can conform via an extension. So in this case, imagine that I'm looking at the same protocol, but now I'm back to my original user class. It doesn't itself, at declaration time, implement that interface, or sorry, conform to that protocol. But I could define an extension somewhere else in my code where I said, okay, here is where I'm going to make user conform to that protocol. I will put my definition of the initials method right here, and then, oh, yep, that thing. That was the syntax for saying that. This is exactly the same as it would have been before. And now, later on in my code, if I ask, is this user that I have an instance of initials provider, the answer will be, yes, it is. So this is not like super wow because I own the class user, so I could have put it wherever I liked. However, if I replace user with like a platform type that I don't own, this still works, right? So I could say, I want this platform class to also be an initials provider. I don't know why I would want that, but I could do it. Womp womp. This is not a thing in Kotlin. So I cannot...
That's called retroactive modeling.
Retroactive modeling?
Yeah.
That's
So
a
you can put it in
cool...
your talk.
Thanks. I will. Remind me again after this talk, because I will forget.
If you're doing it for types you don't know.
Yes, yeah. So that is a thing you cannot do in Kotlin. So I could sort of, we saw how I could have my user type implement this, but if I was trying to have some other type that I didn't own implement this, the equivalent interface, then that's not something I'm able to do. Relatedly, in Swift you can have constrained extensions where you provide functionality only if you are yourself of a specific type. So this would be a way to, if I had a progress indicatable protocol, this would be a way to say, okay, this is the way that you conform to that protocol if you are yourself a UI view controller. And you can also do things like this. You can extend a collection type, say, and make there be restrictions on the elements within that collection type and only provide the functionality if those elements are themselves conforming to some protocol. In this case, it would be equatable. Again, neither of these are available in Kotlin. With these shocking revelations of the last two slides, you might be thinking about Krusty and architecture and what this means for the comparisons between architectures of the two platforms. I know this is maybe a little bit of a danger zone, but I'm going to go there anyway. So protocol-oriented programming is like the Swift way, right? It was built with protocols as really, really first-class citizens. And as we've seen, they slightly extend their capabilities when compared to things like Kotlin interfaces. So this means if you were working on a code base in one platform and you wanted the other platform to easily be able to follow along and share code and share architecture, you cannot really go full protocol-oriented in your iOS application. Having said that, there are lots of really good alternatives. I have built recently an application based on MVVM that was mimicking the architecture of an iOS application that was also built with MVVM, and it was joyous, to say the least, to be able to just steal bits, but like patently steal bits from one application and use them for the other. So I'm going to say a little bit about this, not a huge amount. I'll leave it to you to decide whether you can bear to not follow recommended guidelines for Swift architecture in the name of cross-platform unity. So just a quick run through of what MVP, is everyone familiar with the acronym MVP, Model View Presenter? Okay, so I'm just going to run through what it looks like on both platforms pretty quickly. Again, the point of this chunk is to say, look, these two things are basically the same. Brilliant. So if you're going to doze off, you can doze off for another couple minutes. So let's imagine I have a protocol or an interface here called user view. This is going to represent my UI, but with an abstraction layer, and it's going to expose a bunch of methods that I can call to change things in the UI. So it might have a set username method. I will call that, and then it handles talking to the framework classes in the UI and making that actually appear on the screen. And then the companion piece to this is the presenter. The presenter is where I keep all my framework-free logic. So in particular, what's happening here is it's going to hold a reference, possibly weak, to the user view. That view will be injected when you build this presenter. And then the presenter will be told when important things happen in the UI. So right now, all I've added are start and stop methods for when your screen is coming to the foreground and going to the background. But you would also add callbacks here for things like the user tapped a button. You would just tell the presenter that that happened. The presenter would go away and do its thing and then come back to the view and say, and now I would like you to do this as a result. One thing to note here is that this architecture is designed to make testing easy. In particular, when you're the presenter is what contains the logic, or most of the logic, and so that is what you would want to unit test. And because of the way we pass in that user view, and that user view is an interface, we can easily mock that. So I have control over my view. I can assert that certain things are called on my view in response to certain logic executing in my presenter. Brilliant for testing. And then let's see how we would use this inside whatever represents a screen in both of our frameworks. So that would be a UI view controller on iOS and what's called an activity in Android. So again, this is the only slide where I compressed the font ever so slightly. So the most dense slide here. But if you just sort of stand back and like squint, it kind of look exactly the same, right? Structurally almost identical. So this declaration here says, okay, give me a class. In this case, I've called it user VC on iOS and user activity on Android. It extends UI view controller or activity, and it implements the interface user view, conforms to the protocol user view for iOS. In this view, I hold a reference to my presenter. It's not initialized when the class is created. It will be initialized, constructed. It will be initialized slightly later on. So view did load in iOS is kind of similar to onCreate in Android. It's called once when you're building the view. It's not called every time you sort of show and hide the view. So you call through to super and then construct your presenter, inject the view into it. Again, self versus this to reference the current instance. And then you save that somewhere. And then later on, when UI stuff happens, you can just tell the presenter that it happened and wait for the response. So in both cases here, view will appear is very similar to Android's onStart. You call through to super, and then you say, hey, presenter, I just appeared on the screen. If you need to do stuff, go away, do it, and then tell me what you want me to do. In both cases, because this is nullable, I can use the safety referencing operator to make sure that if it's not there for any reason, I don't have bad things happen. And then analogous behavior for on stop when my view is about to disappear. Tell the presenter that we're about to stop if it needs to stop notification observing or whatever it's doing. It can do that there, and then finish tearing down the screen. So again, super fast run through, just to kind of illustrate, hey, the frameworks are like somewhat different and some of the framework knowledge is different, but in terms of the life cycle that a screen goes through, all super similar. You've already learned all this stuff. It would be a shame not to, just shuffle it over to Android and use it there too. Now this is the last part of the talk, and this has the most pictures in it, so it's clearly the most fun. So what I'm going to do is sort of walk through the evolution of layout building on the two platforms. They've been quite different at various times, and they've sort of come together to be in pretty much the same place right now, which is kind of amazing, but also kind of not that surprising perhaps. So this is the iOS story. So in 2008 we had the iPhone, and then in 2010 we had the iPad, and as far as I'm aware at this point, everything was still being built on a pixel-by-pixel basis. Yes? Okay, that is true. So then Party gets crashed in 2012. The iPhone 5 comes out, as well as the iPad mini. That it doubles the number of screen sizes that we have to worry about again. So Apple is like, fine, sometimes you might have to consider things which are going to scale across different devices. Have this auto layout thing which OS X has been using, and start using it for iOS. Which is a good thing that they did, because in 2014 they kind of ruined whatever party you might have been having again and said, okay, now there's another 2 sizes that you need to support on top of the existing 2 phones and 2 iPads. And I didn't even throw the iPad Pro in here, but it's around here somewhere. And then in 2015, they sort of went a different direction altogether and said, here's this UI stack view thing. What it does is it makes building layouts easier, not more powerful. It's not a more powerful tool. It's a simpler to use, more maintainable tool. I built layouts in this period of time before UI stack view. And it was my first exposure to auto layout on iOS, and I was coming from Android. Man, that was the hardest part by far. Auto layout is a super powerful tool, but it can be really complex, with things like showing and hiding a view and making sure that works right. I'm preaching to the choir, I'm sure here, but this is an interesting step to me that they said we recognize that this is hard, and sometimes you don't need all that power, and you prefer to have something that's a little bit easier to manage. So here's the Android story. So this is not what Android looked like in 2009, but I couldn't find a good reference for exactly how many devices there were in 2009. This is more like 2015, sort of the collection of screen sizes that we had. So in 2009 was when Android 1.0 was floating around internally. And interestingly, back then, layout was done in something called an absolute layout, which was pretty much what you would guess that it is. It was a pixel-by-pixel, position things exactly layout. But in 2009, they deprecated it and replaced it with these things called linear layout and relative layout. And both of those are designed to be a little bit more flexible, and they are built to assume that your screen size is not going to be fixed and you're going to have to sort of deal with it. And they gave you tools for doing that. This is before the first public release. So internally they were thinking, okay, we're going to build for absolute dimensions. Before it even made it to the public, they were like, whoa, that's definitely not going to make sense with our vision for Android. We need to accommodate different screen sizes and make it easy to do so. So all of that, the building of absolute layout and the deprecation of absolute layout happened before it reached the public. For some reason, absolute layout is still in the SDK today. Don't know why. But then, in 2017, we got a new tool for Android development, for layouts in particular, called constraint layout. Can you guess what this might be? So this is almost like the opposite. This is the sort of the opposite trajectory of iOS. So what we had initially is, okay, we didn't have pixel precision tools, but we had the easy stuff. We had the we had layout tools that were easy to use to build layouts, but not as high performing as they could have been. So the problem with linear layout and relative layout is that if you were building a single screen with a single directional flow, then it was easy to build using just one of those. But as soon as you started to make more complicated layouts, what you ended up doing is nesting these things. And the way that Android was measuring and laying out its screen meant that nesting, just like on iOS, is an expensive operation because you need to traverse that all the way down and back up the tree in order to put things on the screen. So constraint layout is kind of a return to let's build flat hierarchies so that we don't have nesting, so that they're slightly higher performing. The place we've ended up now in 2017 is that we have fairly similar tool sets available to us. So this trajectory, both of them have moved from precision to adaptive tools. Android, it happened really early on. iOS, it happened a little bit later, driven by the differences in the screen sizes available. We have a general like high power and reasonably high performance option. But then now we also have specialized options that cover specific use cases for UI. This is UI stack view and linear layout, which are more maintainable. They're a little easier to work with and a little easier to set up. So just to make this extra clear, if we look at auto layout versus constraint layout, they're both super powerful. They're both designed via GUI. So for a long time, Android developers have preferred writing XML because we have human-readable XML to define our layouts. As part of releasing constraint layout, the Android tools team spent a long time improving the layout editor within Android Studio. And what their stated objective is that you never need to write XML ever again. So they want to get to the point where all of your design is done via this layout editor GUI. And they're actively soliciting feedback. They're saying, if you as a developer still prefer writing XML, tell us why. Like, we want to know so that we can fix it. The resolution of the constraints that you specify in both cases is based on the same algorithm. So it's not super important that you know what the algorithm is, but the good part about this is that whatever mental model you've built up for auto layout will transfer pretty well to constraint layout because the resolution method is the same. And something which has been a long time coming for Android. Android has had way too many ways of making animations happen in a smooth way. That was, again, one of the fun things I discovered working on iOS was, if I wanted to animate something, I could just change the constraint and say, yeah, when you do that change, just make sure you animate it for me. Constraint layout now lets you do the same kind of thing, which is kind of fun. There are some differences. One is the default behaviors are a little bit different. Android has this weird kind of centering between constraints if you define two constraints and no sort of intrinsic size. And then fallback handling is a little different. So what I mean by fallback handling here is the case where I have a constraint between one object and another object, and one of those things goes away. In iOS, you have to be very explicit about setting up a backup constraint and sort of activating it or giving it a slightly lower priority. That whole system of very fine priorities doesn't exist on Android. You basically have like a one-shot backup. So you can say, if this item goes away, you should instead attach a constraint to this other item. So far, I haven't felt super limited by this, but it remains to be seen if that's problematic or not. So then if we look at the other end of the spectrum, at the easier to use and more maintainable layouts, we have UI stack view versus linear layout. Again, both of these are designed to allow you to build maintainable layouts. Both of them allow you to put things in a vertical or a horizontal sequence. And they both have graceful dynamic behaviors, so I think that's one of the biggest wins versus something like auto layout or constraint layout. If I have a list of elements in this thing and I take one of them away or hide it, then the rest just all move into position perfectly. Same if I add something to the list. One thing that's slightly different between the two, linear layout has a well-developed system of weighting, so if I want to give sort of relative sizes to things or relative sizes to spacing, that's pretty easy. I don't think that's quite as easy in UI stack view, although I thought I saw that was something that was coming. I also saw this library, paralayout, which is a Swift library which aims to bring some of those weighting features to iOS. These are the guidelines that apply when I'm working on Android, and I don't know if it's similar or not on iOS, but I've switched over so that basically whenever I'm working on Android, if I'm in a high performance situation like a scrolling list, I'll tend to try and use a constraint layout because the flat hierarchy is a little bit faster to draw. If it's more important that my sanity remain, then I'll tend to use the linear layout or relative layout options. if I know it's going to be a high churn area of the code, or I'm going to have to change structures significantly, then it's more important to me that I am able to work with my code base. I've done that thing where you delete all of your constraints and start again. It is not a fun thing. So sanity matters, performance matters. The asterisk is there because I don't know if auto layout is obviously not the most high performance option. You still have few enough screens that you could, in theory, still pixel by pixel layout on iOS. I wouldn't recommend it, but it's there. Some more pictures. So this is just a few pictures to illustrate that the environments in which we build our layouts have also converged a little bit over time. So this is the sort of canonical. I'm looking at a UI view controller and I've got a few constraints going on. I have a hierarchy on the left there. I can sort of see visual representations of my constraints and what I'm constrained to and the dimensions and all of that good stuff. This is what it looks like now in Android Studio as of the new layout editor. So they give you sort of a real-time representation. They give you this nice blueprint. Again, you can see this is my selected thing. I can see all the constraints. I get all my dimensions. I can't see super easily here what the encode names of the things I'm constrained to, but it looks like it's just the parent in all 4 cases. And you can customize exactly what you see there. And then on the left, there would be a hierarchy. It's just the screenshot that I managed to find for this doesn't have it. But again, very similar looking environments, very similar kinds of tooling and visualization available to you. And then the other thing, this has been the best steal recently from iOS. So this is I forgot what this is called, the debug view hierarchy, I think it's called in Xcode. This is the runtime way of inspecting your layout. Okay, this is the runtime method of inspecting your layouts, where you can sort of take a snapshot of what's currently on your device and move it around and have a look. Left-hand side is your hierarchy, center is your visualization, right-hand side is your properties for review. This is a super useful tool that has been kind of available but really crappy on Android for a while. And now we got one of these too, hooray. So on the left is your hierarchy. The right, there's no 3D view in the center. There's no 3D view. I know, just a boring flat view. But you at least get like highlighting around the thing that you're currently focused on. And then on the right, this giant list of all the properties you could care about and lots more that you definitely don't care about.
Is the Android version static or dynamic?
It is static. You create a capture and then work with that. The nice thing is that it automatically generates captures in, like the capture is a thing that it generates and saves. I don't know if it's the same in Xcode, but you can refer back to it later.
I don't think you can save the view debugger states separately.
It's kind of fun at the end of a project to go back through and look at all the views, like the weird views you were trying to debug on the way through. But it's not super practical. But if you needed to share it or something, that's something you can share and have someone else look at, which is kind of neat. So that's kind of all I had to say about this topic. I wanted to give a few resources for if you were interested and wanted to learn a little bit more. So the first is this website, Swift is like Kotlin. It basically is a nice presentation of a lot of the stuff that I've shown here today. Takes the Swift version, takes the Kotlin version. It's not perhaps as comprehensive, and it's not really, I wouldn't say it's as complete as what we talked through today, so I don't think it touches on things like protocols and interfaces, which are kind of fundamental, but for the real basics, it's quite nice. And then the other 3 links I have here are all from the Kotlin documentation. So this is the documentation on getting started. The reason I include this here is because it talks you through using IntelliJ to start writing Kotlin. IntelliJ, best IDE ever. So if you're going to start writing Kotlin, there's no reason to do it in anything other than IntelliJ. Kotlin was built by the makers of IntelliJ, in case that wasn't something that was common knowledge. Then they provide these koans, which are really small. The way I think of these is like the 1-inch punch. It's like practicing the 1-inch punch a lot. Each koan introduces sort of one new standard library feature or one new concept from within Kotlin, and then has you practice it from a bunch of different angles. So it's a really sort of, you get to churn through the exercises pretty fast. It's all done within IntelliJ. It's an excellent way to get comfortable with the basics of the language itself. And then there's also a really nice tutorial for if you're going to start using Kotlin on Android, how you might go about doing that. They talk about both taking an existing project and transferring it, and also starting a new Kotlin Android project fresh. So what are the tactics if you were interested in learning Kotlin and Android right now? So the good news is that you can ride the wave at the moment. So because Kotlin was only recently announced as officially supported on Android, there are a lot of people who are learning Kotlin and are really interested in Kotlin. The community is sort of super vibrant. there's a lot of energy around it and a lot of people looking to learn. So if that describes you too, there's a lot of resources around for you. If you're lucky enough to work in a company, say, where there are both iOS and Android developers, one of the best ways I think of picking up sort of cross-platform information is to read PRs from the other platform, especially if you can do it on the same project that you're working on, because then you have all the domain knowledge already available to you, and you can really focus on exactly how the logic is being implemented in the alternate language and ecosystem.
Requests or press releases?
Well, I would recommend pull requests. I wouldn't recommend press releases. And maybe you can get something out of those. I doubt it. Building a small Android app would be my next recommendation. I would keep it super simple. I often like to, if I'm teaching someone for the first time, I often like to run through sort of a small weather reporting application, something which is very minimal in scope but touches on a lot of the common things like networking and moving from screen to screen and persistence. And this should not be too bad if you start out with one of the IntelliJ or Android Studio Android templates. They will bootstrap it for you with Kotlin all ready to go and a starter screen and everything. And then this is a huge win for Java developers, but I would recommend it to anyone who's coming to Android or to Kotlin especially. IntelliJ has this amazing auto-conversion tool where if you paste Java into a Kotlin file, it will just convert it for you. It will not be the most idiomatic Kotlin code you've ever seen, but I've never had it produce non-working Kotlin code. So if you're someone who's already familiar with Java and you'd like to learn Kotlin, this is an amazing way to do it. You can just write what you would like to normally write in Java, have it automatically converted into Kotlin for you, and then sort of diff it and figure out how to achieve things that you would normally do in Java within Kotlin. That's about all I have, unless there are questions.
How do you feel about people trying to get Swift built in on Android?
I think it's interesting. There was definitely talk for a while about whether Google would adopt Swift as an official language. I'm not surprised that they didn't in the end, just because they basically had to do, Google has basically had to do no work to support Kotlin on Android. One thing that I will note is that Kotlin compiles down to JVM bytecode. It also compiles down to JavaScript. And there is Kotlin native, which is Kotlin compiling down to machine code. So there is the possibility that Kotlin will also be running on iOS devices at some point.
Does that go through JavaScript to do that?
I have no idea. That's a good question, though.
I don't think so.
Kotlin native is very early on in development. It's around 0.3, so it's pretty rough around the edges still. I haven't personally tried it, but I think, from my understanding, it's in kind of the same place as Swift on Android is, sort of functionally working, not super developer friendly yet.
Are there server-side Kotlin efforts? Would this be Kotlin
It's a
JavaScript?
JVM language.
It's a JVM language, so you can write it anywhere. You can run JVM. So yeah, there are plenty of people switching over to take any area in which Java is used. You can basically write Kotlin.
Is there Kotlin on a Blu-ray?
Kotlin on the Blu-ray?
No Blu-rays, just use Java.
Yeah.
I have no idea.
Yeah.
Oh. Today I learned.
That's why they're so horrible.
Sorry?
That's why they're so horrible.
That's why it's, oh.
It is. That is why they're so horrible. Because all the menu things for Blu-rays are Java.
Didn't know that. What did HD DVD use?
Oh, who knows?
Well, it lost the war. I was wondering if it was a worse technology than Java.
Probably not.
And the best part is that it's like a Java standard from when Blu-ray first was standardized. So
I mean, that makes kind of sense, but yeah. There are still, I will say, there are still good things about Java, but I prefer working in Kotlin when I can.
yeah, does the Java Kotlin converter work for just like enterprise Java, or is it specifically made for like Android? Or I guess it's an IntelliJ, so
It's definitely not
it's
specific
just
to Android.
general Java.
Yeah, I don't know how it would handle like more enterprisey setups, where there's a lot more sort of the runtime environment takes responsibility for a lot more. I don't know how it would handle those cases. Mostly I've done it in the context of either standalone Java or Java and Android. So
Yeah, and is bridging between Kotlin and Java code like automatic? Does it interpret Java code as Kotlin so you can interface with it? Like,
yes, there are a few things to learn for the interfacing in either direction, but not a huge amount. And another nice thing about IntelliJ is that it will allow you to take Kotlin, figure out what the equivalent JVM bytecode will be, and then decompile that back to Java. So if you ever wonder what your Kotlin code looks like and how you would invoke it from Java, you can just go through that two-step process, look at the equivalent generated Java, and figure out, okay, well, this was a generated class, so I actually need to use a class access syntax here or something. So yeah, it's generally not difficult to figure out how to bridge, even if it's not something you've run into before. And they can exist like side by side in source directories.
So is there something equivalent to playgrounds, where we can just kind of play around with some Kotlin?
Does Kotlin have a REPL?
Kotlin does have a REPL, yes. It has a. I don't know exactly how good it is. So the Kotlin koans, if you look at that, they have like an online version of that where you can write Kotlin in your browser. They call them something, I forget what it is. But if you sign up for an account on the JetBrains website, you can also save these web versions of your Kotlin. Kotlin also supports scripts. So if you end your file with KST instead of KT, then it's a script equivalent that you can run start to finish. It's not as interactive as a playground, but the format there is very similar. That's what I used for generating these code samples and checking that they compiled. I didn't need to build a whole project, so I just wrote a script and ran that with the Kotlin compiler and stuff. So yeah, it tries to be a little bit more developer friendly than Java is in that sense. Cool. Looks like that's a wrap.
Yeah, thanks, Stuart. Thank you.
Yeah, no worries.
Round off.